So if you read this problem, they say that the aeroplane 1, if it hits a target correctly, it is 0.3, and aeroplane 2, if it hits the target correctly, it is 0.3 and then 0.2. Okay, the second plane will bomb only if the first misses a target. That is the condition, and you have to find the probability that the target is hit by the second plane. Okay, so when will the target be hit by the second plane? When the first has missed the target. Okay, remember this. So let us start. Let E be the event of aeroplane 1 hitting the target. Okay, let F be the event of a aeroplane 2 hitting the target. What are we given? We are given the probability of aeroplane 1, that is P of E, hitting the target correctly, that is 0.3. Okay, now what is the probability that he misses the target, that is E dash? It will be 1 minus 0.3. Okay, the complement of a probability is always 1 minus the probability, which is 0.7. Now we are also given that the probability of the aeroplane 2 hitting the target correctly is 0.2. Now we know that the aeroplane 2 hits only when the aeroplane 1 misses the target. So P of F given E dash is given to you, that is 0.2. So now F given E dash is already given. What is asked? The probability that the target is hit by the second plane. So here you can use the multiplication theorem. Okay, using multiplication theorem, that is P of F intersection E dash. Okay, probability of the second aeroplane hitting the target given that E has missed the target. Okay, now this will be probability of F given E dash into probability of E dash. Or you can write it the other way. As you can understand what happened, the first aeroplane missed the target, so its probability multiplied the probability of the second plane hit the target properly, given that the first one was missed. We know these probabilities. It's 0.7 into 0.2, which is equal to 0.14. This is the answer. Okay, next problem. A box contains 4 white balls and 6 black balls. And okay, so there is one box contains 4 white balls and 6 black balls. Then another box contains 3 white balls and 5 black balls. One ball is drawn at random from the first and transferred in the second. Okay, so plus 1. We don't know this plus 1 is either white or black. We do not know. We just know it's picked from box 1 and shifted to box 2. Okay, now, and the ball is selected, and then one ball is selected from here. Okay, and the probability of it of being white is to be found. Okay, this is the situation. So let us start. Let A be the event of transferring white ball from box A, box 1. Okay, Then A dash will be the event of not transferring white ball. Okay. If something is happening, then complement of it is something is not happening. Okay. Now, so next event we need is our probability. Suppose let that be E, be the probability, sorry, be the event of selecting white ball from box 2. Okay. Now what we are given is we have to find the probability of selecting a white ball from the second ball. Now this probability of E will depend on the probability of selecting a ball from the first box. Okay, if it is the first box, from there if you have selected white ball, then it will be different, and if it is black ball, then it will be different. Okay, so let us do that. So probability of selecting a white ball from box 2 depends on two things, that is probability. Suppose the probability of the ball selected from box 1 is white. Okay, then what will be the probability of E given A has happened, plus suppose the first ball chosen from box 1 was A dash, that is not white, then what would be the probability of choosing a white ball from box 2 depends on A dash. Okay, so let us do that. Probability of getting a white ball from box 1 is 4 white balls upon the total number of balls, that is 10. Okay, now why I didn't use NCR formula? Because I'm choosing only one ball at a time, multiplied by P of E given A. Now if I add one white ball to the box 2, then the total number of white balls will be 3 plus 1, that is 4, divided by 5 plus 3 were the original balls, plus 1 is added, so 8 plus 1, that is 9, and plus what is the probability of not getting a white ball, that is of getting a black ball, 6 upon 10, multiplied by white ball will be, now if black ball is transferred in box 2, then the number of white balls available is only 3 upon 9, because total number has been 9 balls after adding 1 ball extra. So calculate this and your answer will be 17 upon 45. Okay.